Today I'm going to walk you through how to take a large language model, pass an investment pitch through it, and have the large language model tell you what it likes, what it doesn't like, and see if you could use it for an aid in your own investment analysis. This is not financial advice, and I'm not a financial professional. All I'm doing is showing you some techniques that I've looked at so that I can better prepare myself for investments in a field that I don't know very well. I'm not an expert in mineral investments, but I'm interested in the field and have been for some time. I run a newsletter called Drift, and I write about the mineral industry on a weekly basis. Let's go ahead and get started. You can see I'm in Google Colab, and my runtime type is just a simple CPU. I don't need a GPU because I'm going to be using OpenAI for the large language model just for demo. Now, obviously, you could hook this up to any large language model instance that you're running, whether that's Mistral or Llama. But I find that just for doing simple analysis of an idea, it's usually best to run it through OpenAI first to get a baseline, and then I can fine tune it later on. So I'm just going to go ahead and get connected, and you'll see here in a second it's going to install just some basics. The two that you'll need to be most familiar with are Langchain and Llama-Index. Langchain, if you haven't heard of it yet, definitely recommend you check the project out. It's just a simple way of interfacing with large language models. They give you some classes that will help you manage the input-output. Llama-Index actually provides you with what's called a vector database. And if you don't know what those are, there are tons of YouTube videos, tutorials. I recommend a few. In fact, I'll put some in the links. But basically, it's a way of indexing your data in vector form, which basically means numbers, so that you can do similarity analysis. So now that we have installations finished, let's go ahead and just get some things running here. So I'm going to use Langchain, and I'm going to use their chat OpenAI to connect with that service. And I want to just initially get my AI model running. You see, I've got my environment OpenAI API key with git pass. Just to see that it's working, let's do a quick OpenAI invoke. And I get this, hello, as an AI, I don't have real-time information, blah, 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 blah. But I can see that it's working. Okay, fantastic. Now, the next thing that I want to do, if I'm on Colab, you can, if you're on your local drive, you can just use your local drive destination, whatever you prefer. I'm on Colab, so what I want to do is I want to connect my drive to output a folder, which we're going to need to output for the actual vector database. So what we want to do next is go and grab the data that's going to be used for the vector database. And if we go into my data folder here for this project, you can see I've got a couple PDFs, and this is the data we're going to load using the simple directory reader. So when we do that, you'll see that Llama-Index goes ahead and grabs the data, and it takes that PDF and breaks it down into pages, and we can see it's like the first page of the PDF file. So it looks like the person is looking for a $5 million investment at a 40% discount. Great. So in Llama-Index, there are a couple of different versions of indexing that we can do. The first one that we'll try is this basic index. This is kind of the vanilla run-of-the-mill. We're just going to load in an LLM, which is OpenAI's GPT 3.5 Turbo, and we've got the temperature set at 0.1. The temperature is just controlling how creative the AI can get. And we've got what's called a service context, and in Llama-Index, that just means how we're going to generate the vectors and what is the large language model that we're going to use when we retrieve data from the database to summarize. So we create the service in context, and then when we create the vector store, we say from documents, we give it the documents that we loaded and the service context. So if we just hit that go. Now, if you're running with a very large data set, this might take some time, and you're running without a GPU, you probably want to have just a small data set to test this out at the very beginning. Okay, we're done. And with this database that we just created, we're going to ask for a query engine. And we can take that query engine and give it the query. And the name of the company is the Tagiuk Gold. I don't know how to pronounce that. My apologies. That's the simple version, plain vanilla. And we can ask it all kinds of questions. How about what is the investment amounts? So the investment amount is 10 million. So that's the plain vanilla. And the next one that we want to do is called a sentence window index. There are actually three main types of indexings that you can do. We're just going to focus on sentence window for now, because in my experiments, I found that that typically is the better one. Though for your applications, you do want to do some experiments just to see what works the best. So let's go ahead and start. We have the sentence window node parser, some storage context like we had for the simple case, and we have a load index from storage. Basically, in this build sentence window index, what we're going to do, just like we did for the basic index, we're going to give it the documents, we're going to give it a LLM and the embedding model, and we also have this save directory. Now, the reason why we do that is because when we create the index, when we create the database, we're going to use the embedding model to generate the data. And you only want to do that once, because if you're constantly doing it over and over, basically you're going to make calls to OpenAI's API, and that's going to cost you money. So I won't go over how we're creating the index itself. What is important is that you understand what a sentence index is. And if I have a sentence window, what I can tell the engine is go ahead and find that particular sentence, but then I also want you to extract all of the data within a certain range above it and below it. I'll throw some links into the comments if you want to learn some more, but that's the gist. So basically you're giving the AI more context to reason over when you request an answer. So let's go ahead and create the index. Again, if you're running on a small machine, this might take some time, but I find for a small set of documents, it's pretty quick. So now we have the index built, we have the database, and now we want to get the query engine. So I've written this function, get sentence window query engine. What we really want is this retrieve type, which is going to give us the documents back that we're looking for, and will allow us to take those documents and then stuff them into a call to OpenAI. So remember, I said that the sentences that we want back are going to be above and below the ones that are similar to the query that we give to the AI model. And so in this function, the one main controlling factor of how much data gets pulled back from the database is the similarity top K. I won't go into detail how it works, but you can look at the Llama-Index documentation to understand how these are working. Let's go ahead and ask it a really simple question. What is the name of the mining company listed in this pitch? And you can see that we're going to get a query engine, which we'll call the sentence window engine. And then we're just going to query it with this question. So let's see what it does. And great. So it comes back with the name of the company, which I'm not going to try to pronounce. And one more quick point. If you're running this for the first time, what you're going to find is when you ask for the query engine, there are going to be several downloads, and it can take a little bit of time, usually no more than about a minute. What I recommend is if you're going to be doing any kind of work with AI, just experimentally, your best bet is to go on Colab first, because you're going to be using Google's network, which is super fast, and the downloads won't take any time at all. Okay, so we have the sentence engine, or we have the means to create the engine, and what we really want to create is this retrieve engine. We'll get to that in a second. Just know that there is another type called auto merge. I'm not going to go over that right now, but you have the notebook listed in the comments section of the YouTube video, so feel free to check that out. Now, what I want to do for my investment technique is I wanted to see, could we prime the large language model, the ChatGPT, to give us some questions about any mining investment, which would make sense for an investor to ask. I thought it could be interesting for people who don't know what they're doing, who are probably somewhat familiar with investments, but don't know mining specifically, which has a lot of unique characteristics to what will make for a good investment and what would not. So in this one, I'm going to ask the AI, basically tell it, you are an expert investor, you specialize in mining investments. So I'm just going to prompt the AI to give me the answers that it thinks that I want. Your job is to create a comprehensive set of questions to be used for analyzing a potential investment. And I want it to use the context below, which we're going to actually parameterize and pass into this prompt and use that context to generate a list of questions that will allow the investor, that's me, to make an informed yes or no decision, as well as a counteroffer to the business seeking the investment. So the way that we do this in Langchain is we create a prompt, and then we take that prompt and we chain it together with an AI, which is the OpenAI LLM we defined earlier. And then what we're going to do at the end is basically parse out the string that the AI generates. For the context, we've already told the AI, look, you're an investment manager. Now I want to give it the specific investment, which is a gold mining project in Nome, Alaska. And then when it outputs the questions, I'm just going to split those on the new line character. So let's give it a go. Okay, so it looks like we've got 20 questions. Did we ask it for 20? No? I've noticed it's really interesting about OpenAI and other models. They have these quirks that you'll find, just as a side note, that some of them will give you 40, some 30, some 20. OpenAI tends to like this 20 questions. Obviously, you could tell it you want more or less, and you could kind of steer it. So now we have this generated set of questions. Let's just take a quick look at them. What's the estimated size and quantity of the gold deposit? Have there been any previous exploration or mining activity? What were the results? Are there any existing partnerships or joint ventures in place for the projects? All right, so it looks like it's asking, good questions that any investor would want to ask. What's the exit strategy? A big one. Are there any potential tax incentives, etc.? So it looks like some good questions. And if you don't want to run this yourself, or if you're thinking, I just want some prefab questions just to test this out, I've actually generated several of them using Llama as for a comparison, and then I just pulled them out one by one and put them in a list. So now we're going to take those questions and we're going to reason over them. And what I've done here is I've got my function call to the query engine to say I want to get a retrieval engine rather than the query engine. And we're going to use that to retrieve the documents in the database. So we have retrieve docs, and I want to pass it a query, and my query is going to be, what is the amount of the investment for this gold mining company? And let's see what it gives us. Okay, so you can see that it's basically taken a bunch of text. What we're doing here is we're saying run the query, this is the response, and then for each piece of text that's returned from these source nodes, basically split them out into a list and then join them together with the new line characters. So if you look here, we have this piece of text, we have this piece of text. It looks like it grabbed a bunch of new line. I guess those must be in the document. Gold royalty stream offer. It's got the name of the company here. It's just going to take all that text and smash it together. So now I have this ability to take all this data from the pitch itself. And what I want to do is take that text and add it to another prompt, which will now allow me to use that text, which we ask up here, and also ask a question about it. Again, for the investment prompt, we say, you are an expert investor, you specialize in mineral investments, and your job is to provide succinct answers to the question below on the given context. So the context will be the actual response to the query that we ask from the database, and then the question will be the query itself. And the way to do this in Langchain is to use what's called a runnable parallel. Again, I won't go into detail about what that is. What you're going to do is ask the question. It's going to be run through retrieve docs, which is that retrieval engine that we defined up here. And then the documents that are retrieved are going to get passed in as the context. So the question will be passed into question, the context will be passed into context. And then we just define the new chain here. So we have setup and retrieval, chain with the investment question prompt, chain with the AI, and then chain to an output parser. So what we're going to do is take the generated questions that we defined earlier. Remember, we had those 20 questions that the AI gave us. And now we're going to take each of those 20 questions and get the context back from the document itself and allow the AI to use that context to then answer the questions. So while this runs, let me explain really quickly. We've got this investment QA chain, which we've defined up here. And there are a couple of commands you can run when you run a chain. When you have a series of questions you want to pass through the chain, you can use this command batch, and it'll take each of those and then pass them through one by one. Again, each question will be put into the question, and then in the context from that question will be generated and put into this prompt and then passed into the AI to generate the answers. It's also important to note when you're running the batch command, this is synchronous, so it's going to go through each question one by one. Obviously, you could do it asynchronously, and you could run multiple threads if you wanted to, which would make it a lot faster. I'm not going to do that here. I'm just doing this for demo purposes. What I'm going to do next is put those responses in a data frame, and I just want to write those out to a CSV file because in case my system crashes or something happens, I don't want to have to run those again. If you have a lot of questions, you can really rack up the charges quickly. So best just to save these to the output. So we can take a look at what questions were asked and just see what the AI gave us. What's the estimated size and quantity of the gold deposit in Nome? Estimated size is not explicitly mentioned in the given context. However, the indicated resource estimate is 79,000 ounces and the inferred resource estimate is 155. Okay, interesting. So it's getting some information. What is the current market price of gold? How's it been trending in recent years? Obviously, we would have to allow the AI to access the internet if we want to do that. There are ways of doing that. I won't cover them here, but you could certainly then branch off from this question and have the AI go out and search the web. I do like the fact that, for example, if it doesn't know the answer to the question, it says it's not specified or it's not given in the information. It doesn't try to ramble on and doesn't try to give me a result that it thinks I want to hear. It just says I don't know. I see any potential legal and regulatory issues. Yes, regulatory issues associated with the mining project could include changes in government regulations, permitting delays, and potential legal disputes. So I would be really curious to know, like the next step would be, okay, so what are some potential legal disputes? Are those listed in the document? So you can see it kind of gives you a way to branch off from what you're reading here. What I also like about this particular approach is it gives you ways to maybe use the AI in unconventional ways for doing an investment analysis. So in this case, you are an expert venture capitalist, you specialize in mining, and I want it to now take these question answer summaries and I want it to carefully reason over them and give me an answer to a question. So just like we did before, we're going to provide it some context, which are the summaries we just generated. And then we're going to give it a question. So let's go ahead and run this cell just to create the chain. And let's see, the questions and question answer summaries, I'm just going to put those together. So before running this, I just want to make sure that we're not going to exceed the token amount that OpenAI gives us. And the token amount for ChatGPT 3.5 Turbo is 4096. And I've just given you a really simple couple of lines of code to check that that's the case. When I run these questions, remember, I'm going to take all of the question answer summaries plus a new question plus the prompt for the AI and then stuff it in and say, give me an answer. So what I want to know is how much money am I going to spend when I run this question? And the way to do that with Langchain is they've got a simple helper function called get OpenAI callback. And when we run that question and answer chain with the callback or under the callback, we're going to see how many tokens we're using. We're going to see how much money it's going to cost us to run this. So tokens used, prompt tokens, completion tokens, and it's basically cost us less than 1 cent to run this. Let's see what we asked it. What are the top 3 to 4 most important questions to ask the entrepreneur about this pitch, which are not addressed in the summary? So let's just see what it gave us. What's the estimated size and quantity of the gold deposit? Remember, there was some contextual information, but there wasn't a complete information. What is the projected lifespan? We did not have the answer to that one. Are there any potential risks or conflicts? And again, we didn't have the answer to those. There were some pieces of information which were interesting. And then what's the experience and track record of the management team involved in the mining project? So I would assume that if you got this pitch deck, you probably would already know the answer to this question. But if it was just out in the wild and you were looking for interesting projects to get involved in, you probably wouldn't have it ahead of time. So, okay, so that makes sense. I like the response I got there. Let's try another one. And what I've done here is basically prompted the AI to say, there's never an ideal investment decision where you have all the data. And the reason why I've added that initial phrase is because a lot of times when you ask modern AI systems for information, especially about anything sensitive like investments or legal advice, medical advice, it's always going to tell you, I don't know, I'm not an expert, I can't give you the answer to that, or I'm not sure, and it will give you a bunch of garbage text that you're not really looking for. So in my case, what I've done is to say, I know that there's never enough data. I'm going to ask it, knowing that, how would you evaluate the project? You must make a decision, and this is another way to prompt the AI. Based on the limited data provided in the summaries, would it make a good investment? Answer yes or no, and provide some context that would make this decision under uncertainty. Well, let's see what it gives us. So we basically spent a little bit more than the last one, but not even 1 cent. And again, like I said, the AI is going to give you a bunch of garbage texts, blah, blah, blah. We know that we can't decide. However, here are some factors to be considered. Positive, previous exploration and mining activities have resulted in the gold produced. The indicated resource is 79,000 ounces, and the inferred is, okay, great. And then negative factors. And then based on the uncertainty, it would be prudent to do more due diligence. Okay, agreed. Didn't actually tell me whether it would invest or not. It just gave me positive and negative. What I would probably do in this case is tune the prompt a little more and play with it and see if I could get it to output an answer. But let's move on to another one. I wanted to know if I was the proprietor or if I was the owner of the gold mine, one of the things I would want to do is to see, could I get the AI to tell me what would make this a better investment pitch deck? And kind of my reasoning for this was probably in the future, people are going to be inundated with all kinds of information, and we're going to be using these LLMs quite a bit for pouring through that, kind of distilling the really important stuff for us. And so if I'm preparing for that future, what I kind of want to do is figure out how the AI interpret what I'm looking for, and then how could I condition my response to kind of get through the AI gatekeeper. And let's just run this and see what we get. Wow. Based on the summaries, the company should improve their pitch deck by including the following information: market price of gold and how that affects project lifespan, production costs, environmental regulations, etc. So basically 16, let's see, 17, 18, 19, 18 of the 20, looks like probably 18 of the 20 questions that were unanswered. It's basically telling me, if I was the proprietor, how could I improve this to make this a better pitch? Great. And then the last question that we want to ask is, based on the lack of information in the pitch deck and knowing that they're only offering a 10% stake for $5 million, can you please produce a range of counteroffers for lowball, reasonable, and high water offers? So the basic idea here is you want to use the AI to kind of give you a negotiating range. If you're not familiar with the process, or if you don't feel comfortable, could you get the AI to give you kind of a baseline for what might make sense? I would not trust the AI to explicitly tell me, this is the way that you should go in your negotiations. I never think that's appropriate. But if you're a negotiator and you're preparing for a negotiation, it might make for an interesting technique. It's difficult to say what the value of the investment would be, but we can offer you some counter offers. The lowball offer would be $2 million. Reasonable offer is $5 million for 10%, and then the high water is $15 million for 10%. Again, I'm not really crazy about this response, but who knows? I would be curious to know actually what happens in the final negotiation. It would be interesting to go back and then look at what the AI provided versus what actually went down in the negotiation. Great. So a couple of key takeaways from this project. First would be, the most important is that whether you're an investor or an entrepreneur, it's interesting to note that AI can reason over the information in a pitch deck and help you fill in the holes. So if you're on the purchasing side, you're the investor, and you want some more context for your decision, and you don't feel like you have everything you need, you can go and ask an AI, and it can provide you more surrounding material around the specific investment. If you're an entrepreneur, same thing. You're not sure how you compare to other entrepreneurs. Are you giving enough information? Are you giving too much? Are you giving too little? This provides a way for you to test that hypothesis. Another interesting thing I've noticed about this project is that to get more out of the AI, you have to provide really great questions. This kind of setup would actually tend to favor people who are already good at investments. Maybe it would make them even better. I think that's probably true too for programming. If you're using a large language model, GitHub, Copilot, whatever, to help you pair program, you're going to get more out of the AI if you already know what you're doing and you know the specific questions to ask at the right time. A couple more things. One is to recognize that you will get hallucinations, or basically information from the AI that's not true or is incorrect. And sometimes the query engine that you're using, like we have sentence query engine, it will not find all the data in your file, or maybe the way that you ask the question is not similar to the text in your data file. And this goes back to point 2. Basically, the better that you can write your questions, the more accurate your query engine assistant is going to be, and the more accurate your responses will get. And finally, you always verify the data with human feedback, especially if it involves anything in finance. So thanks very much for watching. If you like what you see, please give me a like and follow. And we'd love to hear your comments about what you'd like to see in the future. A couple different concepts that I'm interested in, particularly for mining, have to do with evaluating the actual images that are provided. So if you have any familiarity with investments, mining investments, you'll notice that there's basically an assumed understanding that you know basically geological mapping, and you're more familiar with mineralogy than majority of the population is. And that can be difficult. I think it's a great area for AI to kind of come in and help interpret what the data is showing on those graphs, so that people who don't have as much understanding in that field could reason over them with these large language models by translating the image to raw text and then using the AI in the similar fashion that you've seen here. A couple other things that I'm interested in doing, for example, are things like hooking up the AI to the web so it can do follow-on queries for information it doesn't have from the pitch deck. And I'm also playing around with AI tools that will allow you to create what are called agents. So conceivably, you could tell the AI to create a pitch deck for you, and you could give it some basic parameters in a database, and then tell it to go and produce the pitch deck on your behalf. You can find me on Twitter, you can find me on LinkedIn, and I look forward to seeing you there.